Bienvenidos y bienvenidas a nuestra es antepenúltima sesión de esta cuarta semana de la complejidad. Les doy la bienvenida a esta mesa de debate. Será sobre Complexity Science y nos acompañan como panelistas Henrik Jensen del Imperial College, Maximino Aldana del Instituto de Ciencias Físicas y del C3, de aquí de la UNAM, Andrea Saenz Arroyo, del Colegio de Frontera Sur y del C3 también, y Jesús Siqueiros del Instituto de Investigaciones en Matemáticas Aplicadas y en Sistemas de la UNAM. Y nos acompañará como moderador Juan Claudio Toledo del Instituto de Ciencias Nucleares y del C3. Adelante, Juan Claudio.
Thank you, Aleida, for the introductions, and welcome everybody for the next to last roundtable of the conference. In this roundtable, we want to open up a little bit the topics to the subject of complexity science as a science, its position as a science among other science nowadays, and what different advantages complexity science has brought our experts today here in this table. So we have a diverse, I think, selection of experts in their fields, from ecology and mathematical and physical modeling to complexity science itself, the theory, and also social science. So let us open the round table by trying to make a little exercise with you guys. So I want each one of you to try to pick between 3 and 5 words in order to describe what complexity means to you. So I'll give you, the 4 of you, a little moment in order to think that, and then you can tell us the 3 words and maybe elaborate a little bit on why those 3 words represent complexity to you from your perspective in your fields, all right? That's the little exercise we're doing today. So anybody wants to go first? Professor, okay, go ahead. You guessed.
I don't need to say anything. 3 words: study of emergence.
Say again?
Okay. Study of emergence.
Okay.
3 words.
Okay, study of emergence. Okay. So Max?
Organization of matter.
Okay.
Evolution, dynamism, and emergence of properties.
Okay, so I would say big questions, big questions with complexity science, and beauty, and educated imagination.
So to follow up that, I would like each panelist to just give a brief reflection on what does complexity mean in your field of study. Of course, for Professor Jensen, that is his field of study, of course, but if you could elaborate on that. So what does it mean in your field of study, complexity science?
Yeah, I find it a little bit difficult to say more than what I already did. But, well, for myself, it's meant that I move between more abstract mathematical studies of models and trying to be informed by collaborations with neuroscientists, ecologists, economists, and maybe more. And of course, I've made clear that I think a good working title for complexity science is the study of emergence. But it's also interesting to try to think of how complexity science, what kind of science it is. And I think it's like a meta science in the same sense as mathematics is. Although it needs to be informed by all of the various subject fields, any specific knowledge of how systems with many interaction components behave, that is like that's the laboratory for complexity science. And then, of course, it's if it's successful, if there is such a thing as a systematic behavior of emergent properties, well, then it might be a guidance to subject fields also in terms of what to look for and how to organize experiments and so on. It has, I think it already has, but maybe I'll jump to the next question. Maybe I should just stop there. Yeah.
Well, thank you for inviting me to this discussion table. For me, complexity science is looking for the organization laws of matter. If we look around us in this world, all matter is organized at different scales, from the microscopic scale to the galactic scale to the level of the universe. And I think that we understand pretty well the interaction laws of matter, like quantum mechanics, chemistry, gravitation, and so on. But we don't understand why matter is organized at all these different levels. And to me, finding these organization laws or mechanisms, it's the main goal of complexity science. And because we can see this matter organized at the cellular scale, the organ scale, the organism, ecosystems, and the universe, I think that this organization permeates different disciplines, from biology, ecology, astrophysics, but we don't understand where this organization comes from. We see all matter organized around us, but we don't know why matter is organized. So to me, complexity science is finding these organization mechanisms, if you want to call them laws or whatever, but we need to understand why matter is organized over all these different scales that we see around us. If you take Einstein's equations, for instance, and you solve them, then you get the uniform universe with no structure. So it is very difficult. The same thing with thermodynamics. If you take the thermodynamics equations and you solve them, then you get a uniform system with no structure. So we need to understand where this structure that we observe comes from. And to me, this is the main goal of complexity science. And it has to do with social sciences because there is social organization, biological sciences because there is biological organization, physical sciences because also matter is organized physically, and so on. So it crosses many different disciplines. Thank you.
Well, I've been first formed as a biologist and then as an ecological economist, and then devote myself to historical ecology. I will say that the aim of using the lenses of complexity is a little bit, as Max said, understand why and how all pieces of ecosystems were arranged in certain order, and what happened when humanity arrived and start to disentangle that order. And the next question would be to understand how the interaction of human societies could be rearranged the order by putting some goals, and understand with the historical perspective the emergent properties. Yesterday we were hearing our colleague Patricia Balvanera that she talks about ecosystem services, which is in our lenses are emergent properties from the interaction of a series of components from the ecosystem. But we haven't stopped as biologists or as ecological economists to understand which components from the systems are needed to have those emergent properties. Say, for example, the climate regulation, no? Which is hierarchical, it's nested, absolutely nested from a leaf of a mangrove to the including forest and has these feedback loops of that optimize the presence of the pieces of the ecosystem that allow this emerging property to exist. So for me, it's trying to understand with this evolutionary perspective. I normally put the line in the Holocene, which is 10,000 years ago, which doesn't mean that that's right, but we normally put the line there, no? Which where civilization started, and we started in a way to modify the environment. Obviously, since the Industrial Revolution, this has been this modification has increased a lot, no? But that doesn't mean that we don't need to understand which pieces gave us this opportunity of having a stable climate during this geological era.
I'm an anthropologist, and then I did philosophy, and the field that I'm working now is sustainability science. So the thing is with sustainability science is that at least to me, it comes from its very origin from a complex systems perspective. I mean, you can go back all the way to the 70s, 1970s, and you see the work of Holling, for example, who was a person working exactly on complex systems and ecology. Yeah, exactly. We all bow. So, and I think that story where we have complex system from the very beginning of sustainability science has go through a process of evolution from understanding, using complex systems to understand ecological systems, to move to try to understand social ecological systems. Okay, so I think that that very fact that comes from that story, complex system has become somehow a sort of common language for a lot of people who are actually working on social ecological systems and sustainability science. Okay, so for me, that's, I think, one of the greatest achievements for my field, based on complex systems. On the other hand, as you can imagine, trying to understand social ecological systems, it implies, of course, understanding the ecological component and the social component, which is particularly messy, right? And the thing is that because of that, the very discipline is sort of like an interdiscipline. And the point is that complexity science can help actually to articulate what actually for a long time people have been trying to understand from one of either sides. See, like ecology is trying to solve sustainability issues from only one perspective, which is from the ecological perspective, or the people working on the social side, like being completely blind about the dynamics of an ecological system, right? So that's the virtue for me of complexity science in my field. Now, just one more little thing that I would like to say is that how do I use complexity science in my own work in this area of sustainability science? And I do something that is called participatory modeling. So what I do is I use complex systems tools, but I bring them to a community of non-experts, so to speak, okay, to bring out a conversation, okay? So we can all define or try to understand, I have a better understanding of the problem at issue using complexity science tools. Right?
Thank you, Jesus. So I think I'm going to follow up a little bit on what you were saying, in the sense that I would like to ask the panelists now, what makes complexity science different from other sciences? Because if you think of just as Max was saying, the study of organization in matter, right? A physicist could come from his perspective only and say, well, that's what I do. I do physics, I study the laws, right, of science. I mean, we all know, I think in this table, that that is not the case. But I would like you to give a little reflection on what makes it different from traditional science and why it can explain things in ways that traditional science cannot.
Yeah, that's really very important. It's very important in the sense of what I mentioned about UK, that's where the complexity science is not accepted as an entity any longer. So what I see the difference in, as I've said, that complexity science is the only science that focus on these, well, emergence of whatever you like to call it, structures, hierarchies, and so on, and see that as something that can be abstracted out of the specific situations and help to understand the well, necessary conditions and the zoo of possible behaviors and so on, and then bring it back into the different fields. I think it's also nice to think of complexity science as a meta science, in the sense that we're used to having pure mathematics and applied mathematics, and there's no research council that'll say we stop funding mathematics because we haven't done that last year, right? So, and in that sense, it's since it's a meta science, it's absolutely necessary for complexity science to engage through all the different subject fields. But on the other hand, it's not only for complexity science that engagement is important. I think that we already now can see that complexity science has complexity thinking, whatever you like to call it, has, well, this was mentioned, right? That it's been useful in some cases, help to change perspective and so on. What is probably lacking is, of course, an appreciation among decision makers and funders.
Well, I think that what makes complexity science different from other sciences is that the reasons why things happen now come from many different places. So we are facing problems and challenges that they don't belong to just one discipline. They belong to many different fields that traditionally have been considered as different disciplines. For instance, let's think about overweight. Overweight is a big problem in Mexico. Too many people with obesity. And one could naively think that it's just a matter of eating healthy food, right? But nonetheless, if this is the solution, why do we have such a big problem with obesity in Mexico? Because the answer is not that simple. We have economical pressures, we have psychological pressures, we have social pressures, and all these different factors influence the emergence of this phenotype in the population. How are we going to address this? It has to do with even the microbes that we have in our bodies. I mean, the microbiota, they have some influence in this phenotype. So how are we going to attack this problem? From the social point of view, from the economic point of view, from the bacteriological point of view, microbiological point of view, or we have to put all these points together and then study this problem as a whole, not separate as different disciplines have traditionally done the study or the analysis of different problems. And I would like to say that this approach, I mean, breaking up a problem in deep small parts, has been very successful. But now we are facing problems that are not manageable with this particular approach. And it has to do with crime, with obesity, with cancer, with climate change, with so many different poverty, so many different problems that our societies are facing. And not only social problems, but also biological problems, like equilibrium of ecosystems. We know now that, and if we go after one particular species in a given ecosystem, can destroy the equilibrium of the entire ecosystem. It's not that we're just destroying that particular species, or it may be a plant or an animal, but if we go and systematically exploit and kill that particular species of plant or animal, we're destroying the entire ecosystem with consequences that can go beyond that particular ecosystem. It can have planetary consequences. So why complexity is different from other disciplines? Because it is not one discipline. It embraces many different disciplines. This is what makes it different from physics, chemistry, sociology, political sciences, because some problems have to be addressed and studied from many, many different angles.
I won't like to say that we are better than the others, but I will say it. No, than the traditionalists. But using a bush-hauling sample, I mean, our understanding, and we'll discuss later the sustainability goals from the UN. I mean, if you look at with the lenses of complexity, sustainability means totally different things, a totally different thing than if you look it with the lenses of a monodiscipline, no? Because it assumes that we have stable systems. One of the contributions of bush hauling was saying all systems from a leaf to the earth are in continuous dynamism, from stable systems to release phases and reorganization where learning takes place, and then you have a new order that for a little moment of peace give us a certain stability, no? So if you see this from these lenses, and basically his definition of sustainability is the ability to increase adaptive capacity, no? Basically, no? So, and we don't look to this definition of sustainability in the normal world, no? It's, for example, with fish stocks, we say, well, the sustainable biomass to be fishable is 80 tons, no? Something very fixed, like a wallpaper. But in a socio-ecological system, to allow, for example, fishing communities, to allow them to adapt to this variability, you need to have different species that are in different dynamism, no? So basically the lenses allow us to see the problem with the proper dimension. I mean, I feel a little bit arrogant by saying this, but perhaps it's the truth. Which doesn't mean that we have managed to pass the message, no? Which is the second part of this roundtable, no?
Okay, so I will pick up what Max was saying about how complexity science can bring together the different disciplines and talk to each other. And I would like to add something else to that, which is, you can think, like Max was saying, the problem of poverty, for example, right? And then you have different disciplines that are looking at different chunks of the problem of poverty. But I see one of the things that makes different complexity science is not only that it can allow you to see these different chunks, but it cuts through the phenomenon itself. And so you can have this like encompassing view or perspective of the phenomenon itself, right? I like to think about another example, which is imagine the soil of a farm's land, right? How do you find that soil? Do you define it as an ecological system or as a cultural social system? Because its practice is used by someone who has certain practices. They have certain beliefs about the land, right? Like how they grow, and they have an explanation of why do they do the things that they do. But also you can see like the microbiome of the soil, right? And understand only that perspective. But I think complex systems allow you to see how soil is neither one of those, right? Is something bigger, emergent at the end, right? So I think that for me that will be something that is particular to complexity science, that is different from other perspectives.
Thank you very much. So I think the common themes have been, Professor Jensen called it a meta science, and Max and all of you also agree that it's about looking at the problem from different perspectives and trying to find how those perspectives can come together to offer a better understanding than any of these individual perspectives can do about the problem, right? So I like the definition very much. So let's go to a harder question maybe. As Professor Jensen was saying in his talk, in UK, complexity science is no longer recognized as a science in terms of funding. And I think many of us have seen a little bit of that attitude maybe in our lives towards complexity science in terms of criticism of what is that good for, right? And we may just say, well, they just don't get it, what we do. But I think that's not the proper maybe way to respond to that. So I would like to ask you now, why do you think that in some circumstances, some cases, we get that reaction from traditional scientists maybe, and what we can do to try to close that bridge, to approach them in a better way?
Yeah, I think one of the reasons is, of course, that the results of complexity science is very much integrated into subject fields. So you can claim perhaps that it's the responsibility of complexity science if there is a higher appreciation of the interconnectedness of the different problems. But people wouldn't say, how do we demonstrate that that's because complexity science has thought about this? That's difficult. It's not like, say in physics, they discover superconductivity, and that's, no one can debate whether that's from physics. It's definitely not biology, right? So, yeah. So I think that's one problem. Then I think there is some funny mix. I think that people, if you just talk to ordinary friends and stuff, they'll use some of the they'll use the term synergy, for instance. That's pretty popular, right? And they also often say something like the whole is bigger than the sum of the parts. Okay, but at the same time, they'll insist on individuality. I'm me, right? And it's me that matters, and so on. It's a long time ago, at least in the part of the world I live in, that solidarity was, or socialism, or whatever you like to call it, responsibility feeling for the society has disappeared. That's just not on the agenda any longer. So this is, well, that's the problem for complexity science, to figure out why there is this misconception. But it goes together, right? Like if you somehow don't see the discrepancy between talking about synergy and the whole is bigger than the parts, and then still insist that the world consists of independent entities, me especially, and I don't have any responsibility for anybody. Well, if you don't see that, then of course it also follows immediately. Why would you appreciate a science that actually focuses on the collective aspects?
Well, I think that it has to do with the enormous success that traditional science has already had, like producing vaccines and medicines and these devices that for many years they were, studied like separately, the transistors, the screen, the diodes, And then when you put everything together, and then you get this. So traditional science has been very, very successful. And there's one reason for that. And my opinion is that this is the way we naturally think. We don't see the whole picture all the time, not as individuals, not as a scientist. We tend to focus on certain aspects of our everyday lives. And it's quite natural. Then when you come up with a problem that requires you to put together many different pictures, first, there is a barrier, the language barrier. You have to talk to different scientists with different languages, with different concepts. And then if you overcome that barrier, the language barrier, then you have to convince them that what you're doing requires their help, their expertise. And that's not always easy. Why? Because a biologist in his lab, in her lab, she's already doing what she knows what to do, right? And I'm a physicist. I do in my office what I pretty well know what I'm doing, and I know how to do it. But then when a biologist or an economist interact with the physicist, first there is a language barrier, and then there is a conceptual barrier, and then there is a how can I help to solve what you're doing? And for that we need the whole picture, which it's pretty difficult for normal people like us to have. Think about climate change. This is a complex problem, right? Everybody thinks about climate change as a complex problem. Why? We all know what has to be done, right? We all know what has to be done to solve climate change. Why hasn't been solved? If we all know what has to be done, why climate change, when we're crossing probably a tipping point, a point of no return, right? And we all know what we should do to prevent that. Why haven't solved that problem? Because it's not that easy. It requires a larger picture, probably a picture that none of those have, right? We need the synergy working together to actually come up with a solution that requires solving problems that entail a much larger picture than the one we see today. Okay? It's what I think.
Big question. Well, I wonder if the word complexity doesn't help, no? Don't help to pass the message, no? Because it's basically share a group of knowledge that could be applied to physics, that could be applied to ecology, that could be applied to socio-ecological systems, that where mathematics help us to create indicators of how the different parts of the systems are coupled. But we haven't been very successful in pass the message. So I think there was a time where you remember there was a prohibition that the knowledge from the church could be spread among people, no? I mean, and this is a little bit what I think is happening with this society that don't pay a lot of attention to science, no? I mean, for example, I just have to give these numbers here of the percentage of the Producto Interno Bruto, genuine GDP, that, for example, China invests in science, no? 3.5. No, China is 2.2. The United States 3.5. Israel 6.3. No, and we invest 0.3% of our Producto Interno Bruto. No, I mean, we and yesterday someone was using this idea of having a large population allows you to solve problems quicker, no? Because you have, I mean, more minds interacting. But if we are like, even that it doesn't look that we are in poor situations in science, we are in poor situations in science. So I think budget is one of the reasons that for why we haven't passed the message of the importance of having this interdisciplinary approach that addresses complexity and that uses the tools that complexity offer us. And the other is that we as scientists don't have binding our conclusions are not binding for the government. So that is for lawmakers, that is a challenge in successful countries, for example, Iceland, that I review in my popular science book. If the science committee decided that you need to close an area because they are receiving big data from the fisheries, no? And they realize that the fish is in a anticipate breeding season, they close the area, and the other day the fishers are obligated to don't fish in the area. So, but they have the authority, which we don't have. So, in a way, I think we are like floreros, ¿cómo se dice floreros? Flower pots, no? And we need to fight for having authority to make policy recommendations. Otherwise, we are going to have very entertaining conferences while we see how the planet is collapsing, no?
A useful flower pot. Yeah. Okay. Good. So I will go back to my own experience and work. And I will start with something that Max was saying a moment ago again, which is, I guess I could phrase it as, so we live in a complex world, but we think linearly, right? Like in a very simple terms. And now what do we do, or me and my team, is that we have to work with policymakers, with farmers, with fishers, with all sorts kind of people, okay? Now, the thing is that my challenge, or what is interesting to me, is how can we all come together and define the problem of interest together, so we can have the perspective of each part of the participant in that we're talking together. Okay. Now, the way we do these things is, as I was saying at the beginning, we use complex systems tools. For example, one of them could be ABMs. Okay, so we model the system and we bring the system and we all discuss the system. But to be fair, what we do is that first we get the perception of each participant or each group of participants. And then that perspective, we make it translated into a model. Okay, that model, the kind of models that we use are called fuzzy cognitive systems or mappings, right? But that fuzzy cognitive map can be represented as a network, as a dynamical network, or if you want to, you can actually have it as a dynamical system with equations, right? Okay. But from that network, we create games. So the thing with games is that you make people to live the consequences of their own beliefs. And that's how you can bring out the conversation about complex systems. How do we actually live in a complex system? And for me, that would be like a way, or at least that's the way we do it, to cross that line to bring out what we know and actually what they actually know, but make it explicit. And most of the times, that reflects a complex system.
I just want to add to what Andrea just said. Imagine that I have a pretty nice solution in my computer, in my lab, for a particular problem. Let's say, violence. in a given city. Now I have to convince the authorities, politicians, to implement this solution, right? That's also part of the problem, right? Convincing the decision makers is part of the same problem. So and this is what makes it very complex, because it's not just about solving violence in my computer. It's about implementing my methods in the society. And to do that, I have to solve another problem, which is part of the same problem. See? And this is where complexity comes about. Thank you.
Thank you, Maxi. I fully agree that how to convince the politicians is part of the problem, and it's a complex problem by itself. That is the point. So, okay.
Yeah, I totally agree, but that depends on the goal of the system. And if you don't have a agency to define the goal of the system, if the system, for example, the socio-ecological system has the objective, which now has it, to maximize profits and not to sustain or to solve climate change, then you don't have agency to change the problem. Yeah, that's my point.
Yeah, but I think it's part of the problem, which is what Max is saying, right? We have to find ways to efficiently, effectively transfer this knowledge to whoever has the authority to make the action happen. But anyway, in order to finish the roundtable, one last question, which is a brief comment from all of you of complexity scientists. What can we do to have a more impact as complexity scientists in the world and in science?
Okay, I'll start with Max's comment. In general, I think that one of the big problems is that we haven't managed to persuade everyone that the world is on-TIG open, as you can call it, right? Certainly all complex systems are on-TIG open. It's the exact opposite of how we as physicists used to work, where we define a system, maybe as a closed system, in the sense that now we have included all what we want to consider. And that approach simply won't work for complex systems because there really isn't any boundary anywhere. An example of this failure, I think, is Brexit in UK. One of the reasons that people were persuaded to, well, it wasn't many, right, but it was enough to vote for Brexit, was this idea that suddenly the country was receiving a lot of people from abroad. And the funny thing was that after Brexit, UK received even more people from abroad. And there is a reason, of course, namely that the UK economy is built on receiving people from abroad. And this aspect was simply not considered. And I guess for people who voted, I have an example. Somebody said to my wife, who's working in a hospital, that you can just see all the money that the national health system waste on translation of English into Hindi. And like that would help, right? Now the point is, of course, India was never part of the European Union, so it didn't cover the translation cost. So this kind of misconception that you can think of some little part of the world and think that if you just manipulate that, then maybe we solve the problems. That misconception is very much alive, and we should use our insights in complex systems, try to persuade people that this doesn't work. Another thing that I think we need is to understand how we strike the balance between detail and simplicity when we make investigation. So I try to argue of these O'Keefe-Einstein propositions, and that simplicity is very important. I think that's the case. You can only identify important mechanisms by trying to gradually include the entire complex structure of causation. But of course, there is always the danger that if you oversimplify, you simply don't understand what is going on. So this is something we need to know better. And that's, of course, a specific question. It needs applied complexity science case. then I think that it's easy for me to say that, oh, complexity science is the study of emergence. But the point is, of course, it's very difficult to identify the emergent structure. So I still think that one of the reasons that we are in political trouble is that we didn't finish the work that Karl Marx started. We don't know who are the building blocks. New Labour thought that this was really smart with the stakeholders, and now we understand how things work, but history demonstrated clearly that was completely useless. So I don't think we know. We know things that corruption is a problem and whatever, ownership is completely screwed and so on, but we still don't understand what the groupings, the emergent entities in society are. And if we knew, then maybe we could more easily navigate the policy. Yeah, the final thing I can think of is that, but I've more or less said it already. I think we need to teach complexity ideas, complexity science in schools, kindergartens, wherever. And I see that not least as a way to combat this idea that all of us are alone and it's just me that matters and I don't need to take care of others, or others don't need to take care of me, or whatever. So that would be important.
Well, I don't know how to answer this question, but it's really difficult. But I think that we are going against 3 centuries of way of thinking in science. Traditional science has been there for about 3 centuries now, and complexity sciences have been around for 20, 30 years. So it is, and traditional science has produced great achievements, as I mentioned before. So we're going against this traditional way of thinking that has lasted for 3 centuries, or probably a little bit more, with impressive results coming from traditional science. How we can overcome that? With results as well, with amazing results, the same way as traditional science can have provided, right? So the only thing that we can show that complexity sciences are necessary is showing that we have solved problems, that we have solved actually important problems, as traditional science has already done. I think that's the only way. Otherwise, there is only willy-willy and blah, blah, blah. And, but just with results. And I think the results are accumulating in complexity sciences every time more.
So I think that's absolutely spot on. So isn't that a task for C3 to actually make a list of achievements? Like, say, cancer. I think the way cancer is now considered as a systemic problem is probably, well, it's difficult to prove, but you would certainly argue that that might have been influenced by systemic thinking coming from complexity science. And there isn't anybody that we should write a paper or a little booklet or something that tried to list all the places where complexity thinking has sneaked in and been essential.
Okay, Bueno, sí. Well, the prohibition was from the church to translate sacred texts into vernacular language. So I think we have there a challenge of translating our vernacular texts from complexity, our sacred texts from complexity to vernacular language, no? And that requires also interdisciplinary work with people that work in communication, to invest funds in communication. I think I disagree that the science of complexity science is really a new approach. Darwin's approach was a complex view of the world. I mean, there was not the name of complexity science, but he achieved what he achieved because he put all the pieces together, no? And I mean, the same with the great achievements of science. So I think we need to highlight that basically these great achievements have historical achievements of science have come from looking at the whole parts of a system and put it in a vernacular language. And also, I think we need to fight for two things. First, having a real agency in decision making. We need to understand that natural system, the difference between evolution of natural system and socio-ecological systems is that we speak. And we can put a goal and we can say, this is what we want. So in this modern area, we have left the market to decide what we want. We haven't put the energy to decide together what do we want. And I'm sure that if we make some of your workshops, we don't want to destroy the planet. So we need to talk about socio-ecological systems and that goals need to be settled by society in a democratic way and not by markets in a random and chaotic way. And saying this like loud and, how do you say it in English? Loud and strong and loud, no? Fuerte y claro, no? Because that's our only hope to stop the environmental crisis that we are facing, and include the percentage of the Producto Interno GDP in very, very significant in making science, no?
Max?
Yeah, I really like your example about that thinking in complexity. Actually, as far as I know, Darwin's natural selection predicts adaptability. Is that right? I mean, it predicts that organisms will become more and more adapted to their environments. It doesn't predict complexity. And in that sense, bacteria are the most well-adapted organisms on the planet. So from Darwinian's point of view, we should have evolved beyond bacteria, because they are even more adaptable than us. So that means that complexity is been around, but it hasn't been so long, right?
I think estamos en el tiempo.
Muy rápido. I mean, some of the parts that are taken by evolutionary modern evolutionary socioecologists that from Darwin work is system evolution, which is, you are talking about individual capacity, but Darwin addressed and modern ecologists are tackling the problem of how systems evolve.
Okay. Thank you. And to finish up, Jesús.
Thank you. Okay. Well, I think I will begin with something that you were saying. The thing is, if by impact we mean influence, right? And the way we're thinking is influence, like in the way we live. Well, I guess that's like mainly the area where they were thinking that complexity science can bring some good or can have more impact because it's helping us to live better, like the planet, right? It's a way of saying. And of course, again, I will go back to sustainability science. And sustainability science is an interesting kind of science, which I think is very different from others because it's a normative science. It doesn't only tell you about things or about how things work. It also tells you how you should do things. Okay, and that's kind of complicated. It's normative. Exactly, it's normative, right? So the thing with complexity science in that scenario, for me, will be that, yeah, it's important that complexity science can show it can solve important problems, and it has like a nice portfolio to show off, right? But also, it might have to, at least part of the community, to move into something. See, as in medicine that you have translational medicine, well, maybe we need some sort of translational complexity science, right? That can actually deal with also with describing and understanding how systems work, but also can be part of the conversation on about the normative part of how do we want to live, or how should we ought to live, right? So for me, that will be a way for complexity science to have a little bit of more influence.
So thank you very much. This is the time we have, and I think we will open to questions, right? Thank you, everybody, and thank you to the panelists.
I'm not going to ask a question. I'm going to answer your question. The answer is keep working.
Thank you very much for this very interesting round table. Well, I wonder if to be involved in the ontological question, if complexity is or not the science, probably is not the most fruitful way. For instance, if we consider from the perspective of analytical philosophy and philosophy of science, the definition of science, one of the definitory properties is that it is linked to a specific domain, and that is obviously not accomplished by complexity. Another perspective, for instance, to think in terms of a meta-sciences. The problem is, again, what is the difference with philosophy of mathematics, philosophy of biology, or sciences? And to think in terms of perspectivism present the problem that every single domain keeps its epistemical identity. Then I think that probably it is better to think complexity as a new epistemological approach, whose goal is to transform, translate, and coordinate the epistemological assumptions, methods, theories, and results of different sciences in a second level epistemology and a common language in order to solve what has been defined or modeled as a complex problem. I think that it is very interesting at the same time to think that interdisciplinarity and transdisciplinarity are necessary, but not necessary in sufficient conditions, because we can have interdisciplinarity without complexity. History of science is interdisciplinary. It's something which is beyond interdisciplinarity and transdisciplinarity. And from this perspective, I think that we can move from the problems about, I don't found complexity because it's not a science. Yes, but we are not talking that it's a science. It's a new epistemological way of thinking. Thank you.
Yeah, of course, I disagree entirely. I think just from the experience I have in UK, you can't get a science research council to fund something that's not science. That's one problem. I also disagree that it isn't a science. It's a science in the same sense as mathematics is a science of patterns, or the same way as physics is the science of how the motion of inert matter is. It's just that it might be a little bit difficult to spot the subject matter. But that's why I point to emergence. The features of emergent properties used across complexity science, across complex system science all the time. Take, for instance, criticality. I think we heard about it many times during the 3 days. It's more or less a paradigm at the moment. The healthy brain has to be at criticality, is the saying at the moment among neuroscientists. And they got that from complexity science study of how systems can organize themselves into a specific kind of state. That is a very valid subject matter for a science.
Yes, in relation to these problems, I think I agree with Dr. Cáceres says that probably the fact that some colleagues just don't get it, as you said, is probably because we are not passing the message in the right way. If we are, I'm going to say it very plainly, if we are going to sell it as a science, big science, a new science, something as big as the other science, the reaction is very clear. What is the reaction that we will get? In a different way, following the words of Professor Jensen, I like very much when he was talking, not referring not to complexity science, but to complexity thinking. And I think that should be the way in which we should approach our colleagues. Because it's not that we have a big methodology like the mathematics, a lot of theory. This is just a baby that is burned a little while ago. So I think we will get complex systems is different. It's easier. Systems where there is emergence, where there is also self-organization, you know, all the things we know. And if we say the difference between them and us is that we are studying the same systems, but we are studying different phenomena there. We're studying the phenomena they are not studying. We are studying this emergent phenomena that they don't study because they reduce su aproximación reduccionista, his reductionist approach, no? Don't let them reach them. So maybe that's what I would suggest to change our narrative.
Okay. Thank you very much. I think, are we running on time, Aleida? Okay, maybe one last question from the audience. I think over there. Hace rato.
Okay, so my question actually goes in the follows the same things that people have already asked. And in the first instance, I would like to say that when it comes to this question about where does complexity come from, there's also an epistemological way to see this, and it's that the approach to complexity comes first from a physics perspective. However, based on the works of the likes of Robert Rosen, he argues in a chapter in a book called Quantum Implications that the living biology is the generalized idea of science, and physics is just a consequence. So maybe just because this view of physics has led us to incredible results based on pure epistemological reasons, that doesn't mean that it's the way we should approach this. So what I would like you to know is how much do you think that this approach would work? Thinking more as a biology, as a general case, and by studying it as that, how much we could discover of these emerging properties, complexity itself.
I think that's absolutely correct. So physics, of course, has many limitations. It won't be very useful for adapting to systems and so on. Whereas biology, with evolution, mutations, and so on, it has a tradition that is closer to complex systems, perhaps.
Well, I would like to answer that. Complex systems, the beauty of complex systems is that they have shared many things in common. It doesn't matter if it is a biological system, or economical system, a sociological, political, or physical system. They have many things in common, and I think that the way, for me, the right approach to talk about complex systems is not prioritizing physics or biology, but focusing on the many things that they have in common, regardless of where they come from.
So let's thank the panelists here. Thank you.
Thank you very much.